Assalamualaikum and hi to everyone for those who watching our video, including to our doctor. So today, in this video, our group from group 1 will present to you guys about classroom and laboratory allocation. In this video, we will discuss based on our table of content, which is summary of analysis findings, justification of algorithm selection, explanation of analysis decision, demonstration of group autonomy and responsibility, and lastly, justification of overall recommendation. Based on the report, this project analyzed 3 algorithms, which is brute force, greedy, and recursive backtracking, for solving the classroom laboratory allocation problem, where classes must be assigned to room while satisfying constraints like capacity, equipment needs, and scheduling conflicts. Firstly is a brute force. Brute force guarantees an optimal solution by exploring all possible combinations, but its factorial time complexity and high space requirement make it impractical for real-world application with large data set. It is best suited for small-scale problems where accuracy is prioritized over speed. Secondly is greedy algorithm. Greedy algorithm offer fast and memory efficient solution by making locally optimal decisions, such as prioritizing large classes or specific equipment needs. However, it reaches suboptimal result due to its short-sighted approach, partially leaving some class unassigned or causing inefficient room usage. Lastly, is recursive backtracking. Recursive backtracking strikes a balance, systematically exploring room assignment while pruning invalid paths to improve efficiency. Its time complexity is exponential, but it manages constraints more intelligently than greedy, and it's significantly faster than brute force. For moderately complex problem, its space complexity is linear, as it only tracks the current assignment path. The key finding that we get from this report is the first one: greedy is the best for large data set requiring quick, approximate solution, and brute force is only viable for small scale and problem where correctness is critical. And lastly, recursive backtracking provides the best balance between correctness and performance for moderately complex scheduling tasks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naskina and I will explain about justification of each algorithm selection. So first is brute force. Brute force was selected because it is simple, easy to understand, and effective for small-scale problem. It works by trying all possible combination of classes and room assignment. Okay, second is a greedy algorithm. Greedy algorithm was chosen for its speed and practicality. It made the best possible decision at each step, such as assigning a class to the smallest suitable rooms, without considering the entire solution space. Third is recursive backtracking. Recursive backtracking was included because of its flexibility in handling constraints. It assigned classes one by one and backtrack when a conflict occurred, such as scheduling scheduling overlap or missing room feature. 4 is other algorithm, such as dynamic programming, branch and bound, or divide and conquer were not selected as they are more suited to problem with a specific structure or require more advanced implementation techniques. So I think that's all for me. So let's move on to the next person. Thank you.
Hello and Assalamualaikum. My name is Nurul Shahida binti Muhammad Shafri. My matrix number is 078058. So today I will explain recursive backtracking and how it used for scheduling rooms like classroom and labs. Okay, the first one is the application. Recursive backtracking helps for scheduling problem by assigning room to classes based on needs, like room size, equipment, and time availability. The algorithm tries to assign one class at a time to a room. If the room fits, it moves to the next class. If no room fits, it goes back and changes the previous assignment. This backtracking repeats until full valid schedule is found. This method is useful because it guarantees a correct solution if one exists. Okay, the next is time complexity. In the base case, each class get a room on the first try, so the time is big O of n, where n is the number of classes, but usually the algorithm tries many combinations by making the time much longer, up to big O of m the power of n, where m is the number of rooms. For example, with 6 classes and 4 rooms, the algorithm may check 4,096 possibilities. Now, space complexity. This algorithm uses memory efficiently because it only remembers on the current assignment it is testing. The space needed is big O of n, depending on the number of classes. This makes it good for systems with limited memory. Finally, the trade-off. Recursive backtracking is very accurate since it checks all possible room assignments, but it can be slow if there are many classes and rooms. Because of this, it is the best for smaller tasks like scheduling exam or special lab session, but not for semester timetables.
Hi, my name is Nur Manila and I will tell you about the demonstration of group autonomy and responsibilities. So, one of the key strengths of our project was the high level of autonomy our group maintained. From the start, we took full ownership of planning, setting goals and managing our timeline without relying heavily on external guidance. So, we carefully assign roles based on individual strength. This allowed each member to contribute meaningfully and confidently. To ensure accountability, we held regular check-ins to track progress and support each other. When challenges came up, we didn't wait for direction. We came together, discussed openly, and found solutions collaboratively. This proactive and responsible approach not only helped us meet deadlines, but also strengthened our teamwork and problem-solving skills. Overall, our group functioned like a well-coordinated, self-directed team. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zaid Arshad Bakri and my metric number is 077613. So I will explain about the conclusion part in this project. So our project focused on solving the classroom and laboratory allocation problem in a university setting. So the goal was to assign suitable rooms and labs to schedule classes by considering room capacity, equipment requirements, time slot availability, and avoiding conflict between overlapping classes. So we analyze and compare 3 algorithms to solve this problem. So first we have brute force. So brute force tries every possible combination of room and class assignments. It guarantees the best solution but is too slow and inefficient for large input sizes. And then it is not practically in real time or large university environments. So next we have greedy. So this algorithm quickly assigns room based on the best available option at each step. It is very fast and memory efficient but may ignore feature conflicts. And then also greedy algorithm useful for fast allocation with fewer constraints but result can be suboptimal. So last but not least, we have recursive backtracking. So this algorithm explores possible room class assignment one by one and backtracks if constraints are violated. And then it provides a balanced solution, handling constraints better than greedy and more efficient than brute force. Also, it is suitable for moderate size problems with multiple constraints. So, in our case study, we stimulated the allocation of labs and classroom based on realistic university needs, which is matching class sizes to room capacities, ensuring the lab were allocated to subject that required equipment, and then preventing double bookings and overlapping sessions. So, final recommendation, we recommend that recursive backtracking is the most suitable algorithm overall. It is because it efficiently handles room constraint, time slot, and lab specific needs. It gives accurate result without the extreme cost of brute force. Also, greedy is still a useful backup for very large or time-critical tasks when quick decisions are more important than perfect accuracy. So, in a conclusion, the choice of algorithm depends on the size of data set and the balance between speed and solution quality. Recursive backtracking is ideal for classroom or lab scheduling in most university settings where both accuracy and constraint handling are important. So that's all from us. Thank you.